Hi, thanks a lot for listening to this short video on how to implement a hypothesis test in SPSS. In this short video, we're going to show you how to implement many hypothesis tests as well as interpretation using SPSS. We'll focus mainly on different student tests, especially tests that allows you to compare mean. So that's one sample student test, independent sample student test, as well as one-way ANOVA in order to show you how to take some decision in practice. So we'll very focus on interpretation. We'll also show you how to make a Chi Square test using cross table in SPSS. So let us start with student tests and their interpretation. One sample student test is a test in which we have one sample, one variable in which we are going to test for if whether or not the mean of the sample is equal to a certain value. So, for example, in this database, we have many information, including the age of the patient in our database, and we are going to test for if whether or not the mean is equal to a certain value, for example, 30. So to make one sample student test in SPSS, just go on analyze. When you are on analyze, go on compare mean, and there are many options here, and just choose one sample student t-test. So you click on one sample t-test. The first step is to select the variable that you are going to test. Highlight this variable and use this arrow to put it into test variable section. So while you have put your variable in variable test variable section, you should choose the value of the mean that you are going to test for. So here I'm going to test if whether or not mean of my sample is equal to 30 years old. So as I have put here in the test value, the value 13, I can just click on OK, so that result of my test here. So age, we have many information in our variable age, which is 443 person in the sample. We have the mean, which is mean of 35.22. We have the standard deviation. So a very interesting table that we are going to use in order to analyze and find the conclusion of this test is the second table here, which gives the t statistic of negative 15.62. The degree of freedom is 442, and here is the p-value in the third column of our table. Of the fourth column of our table, we have is a p-value which is 0.000. Our p-value is less than 5%, meaning that we should reject the null hypothesis, which was set as which say that the mean of our sample is equal to 30-year-old. So we cannot accept the fact that our mean of our sample is 30-year-old. So let us redo our test and choose for a test value just to 25. So you have seen that the mean of our sample was close to 25-year-old. So we click on OK. that in this second analysis, you can notice that our p-value is just equal to 0.459, which is significantly more than 5%, which means that we can just, in this case, accept the null hypothesis, which say that the mean is equal to 25. So in this case, we have to accept the null hypothesis. Sample student test is conceived in order to evaluate the difference in mean between two groups, two independent groups. So we have a variable in which, for example, the age. We are going to see whether or not there are two groups have different mean in age. So for this tutorial, we'll just take an example of body mass index. So we have a database on body mass index recorded on student in secondary educations, both male and female. So we're going to see this tutorial whether or not the body mass index differ from girl to boy. So we have our variable, the body mass index. So to run independent student test, we don't need to go on analyze and compare mean. So you go on independent student test. So you click on independent student test, you select the variable test. So our variable that we are going to test here is BMI. BMI is body mass index. So we use the arrow to put it in the test variable section. So the second step is to select the grouping variable. So here our grouping variable is student gender. We are going to see whether or not there is a significant difference between body mass index among males and females in our sample. So we highlight the student gender variable and put it in grouping variable. So the third step is to define groups. So we have seen in our group that we have two modalities for student variable. For student gender variable, which is one for female and two for male. So we will click on the define group button here. So we enter 1 for group 1 and 2 for group 2. So then we click on continue, and after that we click on OK, and the output will be printed here on your screen. So we have in the first table the group statistics. So we have numbers of observation. We have 1,425 female students and 867 male students. So the mean among the group in the group of male student is 21.34, and in the male population we have 19.74. So we have a standard deviation of in each group as well as standard error mean. So the second table here give information in independent sample test. So what is really interesting here is a value of the student test, which is here, and the the degree of freedoms. We have also the significance of the test. So the very important value here is a significance of the tail, of the two-tailed test. So we have a p-value, the significant, which is the p-value here, is equal to 0.000, which means that you can just reject the null hypothesis, which is the equality of mean between women and female. So we can not accept the null hypothesis, meaning that mean body mass index is different between female and male population. And we come back in our group statistic table, we can see that body mass index is more than among female is more than the one among male students. So we can just think that female students have much higher body mass index than male. ANOVA test is a statistical test mainly designed to search for mean difference between groups. So the aim of the ANOVA, one way ANOVA test is to search is whether or not the mean is different, mean of the quantitative variable differ between groups. So in this tutorial case, we have two different variables. We have salaries and we have different categories. So we have agriculture, we have industry, and we have sales. So these three sectors in which we are going to see if whether or not the mean salary the salary differ between these or can be considered to be equal in these three groups. So to run ANOVA test in SPSS, you just need to go in analyze, uh, compare mean, and choose the last option of the test, which is one-way ANOVA. Then click on one-way ANOVA. So the first step is to select the dependent variable, which is the quantitative variable, to put through this arrow in the dependent list. So the second step is to select the category factors, which is category that use this arrow put in the space related to factors. So we can go in option, choose to have descriptive statistics, fixed and random effects. So we will not select this option because 99% of tests are based on fixed and random effect models. So we select homogeneity of variance to see if whether or not the variance is variance differ between different groups. We also have Brown, Forsyth, and Welsh. So you can also plot the mean plot. You can also do a mean plot. Select the mean plot and then click on continue and then click on OK. So we can the first table that appear in our estimation result is the descriptive statistics. So we have here the salaries, and the first the very most important piece of information in this table are the mean and standard deviation of our variable. We have mean in agriculture, we have mean salary in industry, and as well as services and standard deviation of variable between different groups. So the test of homogeneity of variance is the test that search for the different, if whether or not the variance are homogeneous between different groups. So the most important value to interpret in this test of homogeneity of variance is the p-value, which is here 6. So the p-value here is equal to 0.000, meaning that can consider that variance are not statistically equal. So variance are different among different groups, agricultural, industry or services. So this uh, 3.39 standard deviation in the service group are statistically different to the other standard deviation of in different other groups. So the third table that we have in this result is the ANOVA test, which is the test which give the result about the difference between groups, between means. So we have the number of Fisher statistic here in the last but one column. So the Fisher statistic is 3.73 and the p-value is 0.02, which is less than 5%, meaning that we reject the null hypothesis that mean are equal between different groups. So we cannot accept the fact that mean salary is equal among groups. So in agriculture, industry, and service, the mean considered is statistically different to the mean calculated in the other sector. So we also have robust tests of equality of mean. So we have Welsh and Brown for sites. So we have different degree of freedom as well as p-value that are less than 5% as previously. And in the plot, in the main plot, we have the different value of the plot of the mean salary. So this plot can materialize the difference between the mean salary in different. Chi-square test is a test which is used when you are going to analyze the relationship between two qualitative variables. Instead, when we have quantitative variable, we usually use correlation in order to analyze whether or not there is a link between two variables. But in the case of qualitative variable, we may need to use a chi-square test in order to analyze the relationship between two variables. So run chi-square independence test, just go on analyze. Let us just notice that it's a database on a survey on a company client. You have the gender, you have age category, you have reason of purchasing a specific good, you have payment method, you have the distance between the house of the client and the company where the good is being purchased. So or not. So we're going to analyze the relationship, the dependence of of some of variable in our database. So to run chi-square test, just go on analyze descriptive statistic, cross descriptive statistic. Click on cross table. So when you have click on cross table, you have this interface that appear. So you can select a row and column variable in order to analyze correlation, the link or the dependence or independence between variables. So don't mind if you invert. So if you put in a variable in row or column, so it doesn't matter what when you put variable in row or column. So for example, to analyze the whether or not gender and age category are dependent or independent variables, select for example gender and put it on rows, and after that you select age category and put it on column section. So to perform chi-square test, you go on statistic and select chi-square. Chi-square. So then you click on continue and then you click on OK. So when you click on OK, you have this table results. So you have case processing summary that gives percentage of valid variable. So all variables were put in the analysis, which means that they were not missing variable among gender and age categories. So we have a cross tabulation between gender category and age category. In each cell's concern, we have the count of the cell. So, for example, men which were aged between 18 to 24 were 16, and men aged more than 64 were just 6 in our sample. So we have in the last table chi-square test. So the first line is chi-square. In the second column, we have 6.187 chi-square statistic test with 4 degrees of freedom, and the asymptotic significance here is a p-value which is 18.6%, which means that we can just accept the null hypothesis, which is gender and age category are independent variables. So we accept the null hypothesis, which means that the two variables are completely independent. So we cannot use for the age category, for example, in order to predetermine the gender of a client. So let us look at other variable. We go on descriptive statistic. We choose analyze descriptive statistic across the world. So we remove, for example, age category and choose the reason of payment. So we choose reason of payment. We have already selected chi-square. Continue and then click on OK. So you see that in this case we have a asymptotic significance which is 9.5%, which means that if we consider a 10% level, we can just reject the null hypothesis, which is the independence between the gender and the reason. So we cannot accept, we cannot reject, we cannot accept the independence between gender and reason. So the reason of payment can predetermine the gender of a client. It can mean that there are some reasons which are more used by some gender categories. So that can be the explanation of the result of this, that if you consider a 10% level. Let's look at second reason variable, reason 1, reason 2. So we can see that reason 2 are highly significant, which mean that so the reason are price, commodity, service, and others. So can we have a asymptotic significance which is significant even at 1% level, which means that we cannot accept the null hypothesis. We reject the null hypothesis of independence. It means that there are a dependent relationship between the reason of and the gender. So there are probably some reasons that are more present in some group categories. So to make a little bit deeper in the interpretation, we can, for example, use port ratio in order to analyze whether or not price influence positively on or negatively in the gender. So that's it for this chi-square test, and we hope we help you understand the chi-square test and the notion of independence between qualitative variables.